Hi all, this is the continuation of our last video, that is eigenvalues and eigenvectors. Here in this video I will be discussing the problems related to eigenvalues and eigenvectors. Problem: find the eigenvalues and eigenvectors of matrix A equal to -5, 2, 2, -2. This is 2 by 2 matrix, so we have two eigenvalues. So first of all, write the characteristic equation, that is determinant of A minus lambda I equal to 0. A minus lambda I is -5 minus lambda 2, 2 minus 2 minus lambda, which is equal to 0. This is determinant of this matrix equal to 0. So -5 minus lambda into -2 minus lambda minus 4 equal to 0. Solving this, we get lambda square plus 7 lambda plus 6 equal to 0. That is lambda equal to -1 and -6. So these are the eigenvalues. Next we want to find the corresponding eigenvectors. So corresponding to lambda equal to -1, we got an eigenvector, and corresponding to lambda equal to -6, we have another eigenvector. Let's see. Corresponding to each eigenvalues, we can find eigenvectors, and it can be evaluated by the finding values for x by solving A minus lambda I into x equal to 0. First of all, lambda equal to -1. Then this equation will be, that is A minus lambda I into x equal to 0 will be A minus lambda I means the matrix -5 minus lambda 2, 2 minus 2 minus lambda into x. This is a vector equal to 0, and this implies lambda equal to -1. So replace lambda by -1. We have -5 minus -1, 2, 2 minus 2 minus -1, and x is the vector corresponding. Here number of columns are 2, so 2 eigenvectors. So x1 in x2, that is equal to 0. Solving this, we get matrix -4, 2, 2 minus 1 into x1 x2 equal to 0. Here we want to find the values for x1 and x2. In the previous video we discussed Gauss elimination method and fundamental theorems, row reduced form, etc. So by any method we can find the values for x1 and x2. Here I'm using this method, that is x1 divided by -1, which means here x1, if we are going to find the values for x1, then eliminate the first row and first column. So the element is -1, so x1 divided by -1 equal to alternate plus minus, so minus x2 divided by, for getting the value of x2, eliminate the corresponding row and column of 2. So eliminating the first row and second column, the element is 2, so minus x2 divided by 2. This is the method. From this we can directly write x1 equal to -1 and x2 equal to -2. So the first eigenvector is -1, -2. Here minus is a common term, so -1 into matrix 1, 2. So here we take the eigenvector x1 as 1 and 2. This is the corresponding eigenvector corresponding to the eigenvalue -1. Similarly, we can find the eigenvector corresponding to lambda equal to -6. Matrix A minus lambda I into x equal to 0 implies -5 minus -6, 2, 2 minus 2 minus -6 into vectors x1 x2 equal to 0. This implies the matrix as 1, 2, 2, 4 into x1 x2 equal to 0. Here also x1 divided by a11, deleting the corresponding row and column, we got 4. So x1 divided by 4 equal to minus x2 divided by 2. That is x1 equal to 4 and x2 equal to -2. Then the vector will be x1 x2 equal to 4 minus 2. Here 2 is a common term, so 2 into 2 minus 1. So here we take the eigenvector x2 as 2 minus 1. So these are the eigenvectors. Next we are going to find the eigenvalues and eigenvectors of a 3 by 3 matrix. Here the matrix is 1, 0, -1, 1, 2, 1, 2, 2, 3. First of all, find the eigenvalues. Corresponding characteristic equation is this. Here finding S1, that is sum of main diagonals, that is 1, 2, 3. So 1 plus 2 plus 3, which is equal to 6. Next we want to find S2, that is sum of minus of main diagonal, that is sum of minus of main diagonal. Here the first diagonal element is 1. So the minor corresponding to 1 is deleting the first row and first column. Then we got the matrix 2, 1, 2, 3. So determinant of 2, 1, 2, 3 plus next diagonal element is 2. So corresponding row and columns must be deleted. So this column and this row is deleted. So the matrix will be 1, minus 1, 2, 3 plus next diagonal element is 3. So deleting the corresponding row and column, then the determinant of remaining 1, 1, 0, 2, 2. So this is the sum of minus of main diagonal. So that is equal to 4, 5, 2. That is equal to 11. So here S2 equal to 11 and S3 is the determinant of that matrix, that is equal to 6. So the equation will be lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. It is a cubic equation. So the values are lambda equal to 1, 2, 3 distinct values. So for each values of lambda we can find the eigenvectors. First of all, lambda equal to 1. So a minus lambda I into x equal to 0 will be 0, 0, minus 1, 1, 1, 1, 2, 2, 2. Into here 3 columns are there, or 3 by 3 matrix. So 3 vectors we need. So x1, x2, x3 equal to 0. Let's see what about the values. Here x1 divided by 0 equal to minus x2 divided by 0, that is equal to x3 divided by 0, which means, go to the previous slide. Here this is the matrix. Here we are going to find the values of x1. So x1 divided by x1 means deleting this elements corresponding row and column. So its determinant, that is determinant of 1, 1, 2, 2. Okay, that is equal to alternate plus or minus. So minus x2 divided by, then corresponding next element is this one. So deleting this corresponding row and column, that is determinant of 1, 1, 2, 2. That is equal to x3 divided by, for x3 these elements row and column, deleting this corresponding row and column, also we have 1, 1, 2, 2. This implies x1 divided by determinant is 0 equal to minus x2 divided by 0, that is equal to x3 divided by 0. So here the denominators are all 0, so trivial solution. So here we want to find the rank of the matrix and then find the solutions. So this way is not possible, so we must find the rank and hence solve the system. So considering the matrix 0, 0, minus 1, 1, 1, 1, 2, 2, 2. Here I am going to interchange the first and second row. So 1, 1, 1, 0, 0, minus 1, 2, 2, 2. Here this elements 1, 2 we want to make 0. So the transformation is R3 changes to R3 minus 2 R1. Then the matrix will be 1, 1, 1, 0, 0, minus 1, 0, 0, 0. Here rank is equal to 2, but the number of variables is 3. So here has infinite number of solutions. We want to substitute arbitrary value to n minus r variables. So by back substitution we got the equations as x1 plus x2 plus x3 equal to 0 and minus x3 equal to 0. From that x3 equal to 0. So here we want to put one variable n arbitrary value, say x2 equal to t. When x2 equal to t, our x1 will be minus t. Okay, because x3 equal to 0. So from first equation x1 equal to minus t. Then the eigenvector will be minus t, t, 0. Here t is a common term. So taking t outside we have minus 1, 1, 0. Therefore the eigenvector x1 is equal to minus 1, 1, 0. Similarly, next we are going to find the eigenvector corresponding lambda equal to 2. Our matrix is like this. Here by the previous method we have x1. Let's write x1 divided by the first row, first column element, that is minus 1, deleting this row and column, that is determinant of 0, 1, 2, 1, that is equal to minus x2 divided by the first row, second element, deleting this corresponding row and column 1, 1, 2, 1, that is equal to x3 divided by deleting the corresponding this elements row and column 1, 0, 2, 2. So this implies x1 divided by determinant of this is minus 2, that is equal to minus x2 divided by minus 1, that is equal to x3 divided by 2. So here this fractions we have x1 equal to minus 2, x2 equal to 1 and x3 equal to 2. Therefore our vector will be minus 2, 1, 2. So this is the second eigenvector. Next, lambda equal to 3. Corresponding vector is like this. By this method we have x1 divided by minus 2, minus x2 by minus 2, x3 by 4. So x1 equal to minus 2, x2 equal to 2, x3 equal to 4. Then our third eigenvector will be minus 2, 2, 4. Here 2 is a common term, 2 into minus 1, 1, 2. So x3 equal to minus 1, 1, 2. So these are the three linearly independent eigenvectors of this corresponding matrix. Next problem, same problem, finding the eigenvalues and eigenvectors of this matrix. Here 3 by 3 matrix, so the characteristic equation is this one, S1 equal to 2 plus 1 plus 4, that is 7, S2 equal to 16 and S3, that is the determinant, is equal to 12. Substituting this terms in the equation, we have the equation as lambda cube minus 7 lambda square plus 16 lambda minus 12 equal to 0. Solving this, we have lambda equal to 2, 2, 3. Here 2 is an eigenvalue is repeated. Okay, so repeated eigenvalues are here. So corresponding to the eigenvalue 2, we want to find one eigenvector. Let's see. For lambda equal to 2, the matrix is like this. Here our previous method does not works here, so here we are solving this using rank. First of all, here the first non-zero element is 1. So we want to make this minus 1 and 2 as 0. That is R2 changes to R2 plus R1 and R3 changes to R3 minus 2R1. So this will be the matrix. Next, moving to the second row. In the second row, minus 1 is the non-zero element. So we want to make this 2 as 0. So the transformation is R3 changes to R3 plus 2R2. That is 0, 1, 0, 0, 0, minus 1. And the last row completely 0. Here rank is equal to 2. This is a 3 by 3 matrix, so n is equal to 3. So we have infinitely many solutions. By back substitution, we have minus x3 equal to 0 and x2 equal to 0. So remaining variable is x1. So we put x1 equal to t. Then the vector will be t, 0, 0. That is t taken outside, that is 1, 0, 0. Therefore our first eigenvector is 1, 0, 0. Next we are finding the eigenvector corresponding to lambda equal to 3. This is the matrix. Here also we are finding the rank. The first non-zero element is minus 1. All the elements below are 0. Then moving to the second row. The second non-zero row is minus 2. Element is minus 2. So we want to make this 2 as 0. Transformation is this one. The last row completely 0. Here rank is equal to 2 and n equal to 3. By back substitution, we have minus 2 x2 minus x3 equal to 0 and minus x1 plus x2 equal to 0. Put x2 equal to t, then x1 equal to t and x3 equal to minus 3. Eigenvector is t minus 2t, t taken as common 1, 1 minus 2. So x2 equal to 1, 1 minus 2. So these are the eigenvectors corresponding to the eigenvalues 2 and 3. These are some exercise problems. Finding the eigenvalues and eigenvectors of this 3 by 3 matrices.